Hello YouTube, De-bodgery here. Welcome to EV Components Review. This isn't a teardown video either, just like my last one wasn't. This is just simply listening to Tricky Chrissy go on about all of his so-called reasonable explanations for the things that I bring up about the KO Moto Rush controller and how they are a bunch of lies. Anyway, I'm going to start off with this character from the Transformers movie, Bobby Bolivia. Love the actor. He does a really good job in this role. It's a really hilarious, scene out of the Transformers movie. I'm not going to play it because I'm pretty sure that that would violate some kind of a copyright thing. But you all know this guy. He's playing this absolutely slimy, sleazy, greasy used car salesman of the worst kind, has absolutely no character whatsoever, will lie to you, tell you anything. The actor does a really good job in being just the sleaziest, slimiest used car salesman that you could possibly ever have. And the first time that I ever ran across anything that Christopher Kleinschmidt ever said, it immediately reminded me of this scene from the Transformer movie, because this is Christopher Kleinschmidt to a T. Just slimy, greasy, slippery, just the absolute lowest possible repute of character you could ever ask for. And now we're going to watch a couple videos where he supposedly explains away things that I say, in so called reasonable terms, but at the same time, he is absolutely lying through his teeth the entire time. So, yeah, when you think of Christopher Kleinschmidt, think of Bobby Bolivia from the Bobby Bolivia from the Transformers movie, and just this greasy, slimy used car salesman type guy who has no character and will lie about everything that he can possibly lie about, and at the same time, be so completely stupid about it at the same time. This is the sort of person that you should never ever trust. Um, like ever. Christopher Kleinschmidt, I have absolutely no respect for him whatsoever, other than as an accomplished liar. That's about his only skill set. It astonishes me that that man can even hold down a job because all he does is just fabricate every time he opens his mouth. And we're going to see a couple of videos of him doing exactly that and amongst a bunch of egregious mistakes and things like that, because he does that all the time too. The guy is clearly and literally a bumbling idiot in every possible way. So, yeah, let's watch him here. This video kind of starts all of a sudden. I don't know if the beginning of it got cut off in the recording of it, but anyway, yeah, it cuts right in. It's almost like he started talking before he hit record on his phone or something.
Something. So I've seen a video online, you guys have probably all seen it as well, pointing out that we have a hole in one of our...
I'm just going to stop it here. Obviously, that video online is me. Nobody else has done a Komodo Rush controller teardown. Clearly, he is talking about me. He just can't ever say so. Later on, he calls me a chap or something like that. He can't use my name. He can't use Richard Gumfa or De-bodgery or EV Components Review because that would give me credibility, and he has none, and I have all of it. But nevertheless, he knows he's lying. He knows their controllers are garbage. He knows that they're just giant band aid after band aid after band aid of an already absolutely shitty design. And that's just how that goes. But, he's right. And I couldn't possibly be right because, well, Christopher Kleinschmidt knows everything and I don't know squat, according to him. So let's listen to him lie a bunch.
bridges, and we have little notches out of these bridges. Also discussing this caftan tape. So I just wanted to, you guys have probably seen the video, I just wanted to give you guys a reason, or the reason why we do things that we do. This particular chap is calling out that we've got holes in the buzz bar. Why would we do that? It creates a whole bunch of resistance, and it's a silly thing. And why would we all these different things? So I just wanted to put into context and give a reason, the reason why we do these things. So
So the reason why we do these things, he said it twice, and obviously I'm that chap. As he says, there's only one person who's done a teardown of these controllers, much to his chagrin, because I exposed the crappiness and the shittiness that these controllers have in them throughout, and how they're just more KO Moto Rush slash KO Pro controller garbage times two, even worse than before. And now he's going to explain away some of the stuff that I've said. Yeah, sure you will, Chrissy, except for the fact that you can't. So the first thing I want you to see is that there's lots of garbage on this board. He later on says, "Oh, this board just came right out of manufacturing." Thing is, though, is you'll see that exact same stuff on my power stages, and mine's a sold completed product. So obviously, when he says, "Oh, they don't stay this way," he is lying because I didn't put all that crap on my board. Nope, didn't do that. They just never washed it to begin with. He's just gonna oh, we don't do that, blah, blah. Yeah, because he's blowing smoke. He's literally lying to you yet again. And somehow or another, it's me that sabotages their products. Yeah, that's how that was. I sabotage your products. Sure. Let's listen to him lie.
So for the first one, you'll see these two bridges here, these two bridges across the FET, the phases there. So you'll see a tiny little notch out of this phase and out of this buzz bar, and a tiny little notch. The reason they are there is because in QC we have to basically QC the power board, and the way we do that is the ladies look up inside here and they check all the arms on the FETs themselves, make sure that they're all where they should be, or everything is honky dory. And basically they do that. If they didn't have this little notch, they wouldn't be able to see past the last leg onto this FET underneath. So if you notice how wide these buzz bars are.
Okay, I'm going to stop him right here. So you just heard him talking about those notches. In a second, he's going to talk about the holes that are in the other ones. I only have one real question about that. Why is it that all four pieces of copper that make up bridges all the same? Why aren't they all the same? Why don't they all have either a notch in them or a hole in the center? And there's a really good reason for that. It's because these are some kind of a copper bar that already had those features in them for some other reason. And they literally cut them to these lengths to put those notches kind of where they are to make it look like they have some kind of actual purpose. The truth is that those bridges didn't exist on this power stage at all until much after the fact. So let me give you a little bit of understanding of how manufacturing a board like this is done. So you have two processes that happen before you do any heating of anything. The first one is you have a stainless steel sheet, and it's got little squares and rectangles and things like that cut in it, and that's so that you can smear solder paste over those areas and deposit it on various and sundry traces. So like this piece of copper right here, this piece, that one right there, all of these small components, all of these brass studs, all the MOSFETs, all those things get solder paste metered out onto the bare MC PCB, metal core printed circuit board, thanks to that solder mask. You can get on YouTube, you can see people that make their own circuit boards and they get a solder mask for it and they smear solder paste over it, with the edge of some kind of a squeegee or the edge of a credit card or whatever. Something like this is done robotically. Once all that solder paste is down, that kind of like glues the parts in place a little bit as well. So then you have another robot that comes along and places all of these components. So these combs, all the little resistors, capacitors, those ones, these brass studs, all the MOSFETs, these pin headers, all that stuff is put in place with a robotic arm. That puts them all in very consistent places, all very nice, neat rows, things like that. Then the board is put into a reflow oven, and it's 360 degrees Fahrenheit, if not more, depends on the melting point of the solder they use. But just typical tin lead solder starts to melt at about 360 degrees Fahrenheit. So anyway, if this is lead-free solder, which it very much likely is, its melting point's probably higher, probably like 370, 380 degrees Fahrenheit. Anyway, your oven is that hot. So this is an environment that is, well, not exactly compatible with humans. You stick your hand in there for a couple seconds and you're going to come away with third-degree burns all over your skin. So if you are going to operate inside one of these things, you're doing it with fire retardant outfits on because it is so damn hot in there. Hot enough to melt solder, right? So anyway, these two bridges on here, they are not in place when the reflow soldering through that reflow oven is done for everything else. They are added after the fact. And there's several evidences for that. The first one is notice the solder on the end here and here. You can kind of see it on the end of that comb right there as well. You can see solder here and here and here and here. That's because all of that is hand soldered. Okay, it's done by a person. The solder doesn't all stay nice and tidy around a solder pad like it does with masking off solder paste. So everything else on here, all this other stuff, the solder paste was put down through a mask. So you get a very specific amount of solder paste on a specific area and not any extra. And you can see here, there is extra solder that Oopsie got on this piece of copper. Oh, this kind of flowed all over the place. That's because that stuff was hand soldered. This bridge and this bridge were added after the fact. And you know that in another way too. They are not straight, they're kind of crooked. That's because a person placed them rather than a robot who does everything perfect every single time. Humans make mistakes, we're not quite so good. In the case of Keomoto, they hire minimum wage people as much as possible who are very unskilled. So they make mistakes a lot. There's sloppy work habits, things like that happen. You look on the other power stage, you can see the bridge that's over here is shifted over a little bit, whereas the other one that's over here is like right up to the edge of the comb. You know, that's the inconsistencies of humans. Robots don't do that. Those things were hand soldered, hand placed after the power stage came out of the reflow oven. So these bridges were not here. Christopher is lying to you about what these little gaps in here are for, what the hole is for. No, what he just said is complete bullshit. They are there because this copper came from something else and they just chopped it up and used it for this. I don't necessarily care about that, but why don't you at least fucking tell the truth about what the copper came from, dude, rather than making up some bullshit story like this? You could absolutely inspect those MOSFETs because those bridges were not in place when the MOSFETs were reflowed in place. Those bridges were added later, much later, probably like the next day or days and days later. They were not added right on top of everything else. Yeah, that's just complete lies and fabrication there. Never mind the fact that there's other things that refute him saying that these are inspection windows so you can see the MOSFETs underneath, and I'll get to that in a minute. So let's listen to Chrissy blather on a while longer, blowing smoke out his ass as usual.
I mean, they're wider than this buzz bar here. They're more than capable of doing the job, but this power stage has to travel a little further.
All right, so I'm going to stop it right there. So this power stage from here to here is narrower than the other one, so it actually has to travel less far, and you can see that this bridge is shorter than it is on the other power stage. So, you know, he looks at the two and just he expects you to be absolute idiots that cannot see the difference in the lengths of the bridges. And then he just says the opposite, and you're just supposed to go, bah, bah. Oh yes, Chrissy, whatever you say. Yes, yes, whatever you say. Let me worship at your feet and suck your dick. Yeah, I know I'm being crass, but let's face it, those are shorter than the other ones are. So him saying that they're longer, you're just supposed to believe him. I don't know about anybody else, but my credulity is broken at that point in time. All right, so since we're here, let's talk about that other thing that's going to refute his little inspection window, statement. So first of all, notice this big ass piece of plastic on here. It's covering half the MOSFETs in this phase. You can't see them, period, because they're all underneath this plastic. These are not holes. that lets you see through to the underside. Never mind the fact that that one's in the completely the wrong place anyway. These are just molding inserts in here, where the plastic was extruded in here. It is high temperature glass reinforced, I will give it that, but you can't see the legs on all of these MOSFETs in here. They're just completely underneath plastic. So his supposed, explanation that these are windows so that they can see the MOSFETs for quality control is complete bullshit and lies. It is not the case at all. You can't see these ones, so guess what? They didn't inspect those MOSFET legs even a little bit because they can't see them. So, yeah, take that with a grain of salt. He's flat out lying to you. Never mind the fact that if you look at this bridge right here, you can see it comes right up to the edge of the comb. That was placed pretty good. You can see all the solder handwork that was done here. If you look at this bridge, you can see that it does not come up to the edge of the comb because it was human placed, not robot placed. And again, you can see all the hand solder work over here. Those bridges were put in place by a human being after this board came out of the reflow oven. Afterwards, way afterwards. So, yes, inspection windows, total bullshit. Lies, lies, lies. Flat out. All right, let's talk about another thing here. So, this board right here is supposed to be representative of how wonderful Moto products are. And yet, Christopher Kleinschmidt can't be bothered with attention to detail. Nope, sure can't. Look up here. You've got three of the five ceramic capacitors here. Three of the five. Where the hell are the other two? They're not on the damn board. All I can say is, really, Christopher, this is what you want to present. You can't even use a power stage that has all of the ceramic capacitors populated on it. You have to use one that's not even a completed product. And then you're going to go on about how we do this, that, and the other thing. And this is representative of your product. All I can say is, Christopher, you should never talk. You should never present products to anyone because everything you say is so full of holes. You can't even use correct terms. You just blow smoke out your ass all the time. You make up bullshit theories for things that are so fraught with flaws. It's not even funny. Everything that you say, Christopher, is just fallacious lies, misrepresentations. It's all right here. I don't even need anything else other than your video to refute you, Christopher, because this is such a load of crap. All right, let's listen to Christopher lie to us some more, because he's gonna.
So what we do is we make this one twice as thick.
He's making a mistake here. He means twice as wide. He'll say that several times again. This copper and the bridges on the upper power stage, they're the same thickness, okay? So he made a mistake there. I don't really care about that. Just thought I'd say that one.
For the obviously for the reasons of resistance and so forth, and then we put a hole right in the middle. And if you can see down there, I don't know if I can get that to focus or not, possibly not. You can see down through that hole. You can actually see the legs.
Doesn't that sound so reasonable? If you're an idiot and you don't know that that's hand soldered, you can see the solder coming out here, that's hand soldered. If you didn't know that, this might sound reasonable to you, except for that I actually know one or two things about electronics and assembly of electronic things, and the evidence is here that completely refute everything that he says about these bridges. They literally were not on this board when this board went through the reflow oven. They were added after the fact. Hand soldering is evident everywhere. The fact that this bridge over here is off-centered, not robot placed, is again evidence of hand soldering. This one here, they got it pretty close. Those bridges were not there. He is lying about what the holes are there for. Most likely, this is some kind of readily available copper bar that they found, and evenly spaced throughout it were these holes. And they just simply cut in between every single set of holes and soldered them down. And then when people would ask about it, or like when I commented, it's like, oh, yeah, that's an inspection port. Oh, you've got to be kidding. No, dude, you bought a piece of copper bar that had evenly spaced holes in it, and you just simply cut the copper so that the holes would be over top of your MOSFETs, and then you made some bullshit story about how it's an inspection port. What a load of crap, Chris. I don't believe you for a second. I know better. Never mind the fact that that third phase is completely covered in plastic and you can't inspect anything on that phase at all. So, yeah, I don't believe you even for a nanosecond. Your explanation is not reasonable, it's stupid. All right, so, look at this Kapton tape. They can't even put it on straight. Can't even bother to put that on straight. And it's halfway underneath this bridge and this piece of copper behind it. So, it's not even soldered down very well because, well, half of the copper is covered in Kapton. Yeah. The quality control here is astonishingly bad. Just horrendous. Let's let Chrissy lie some more.
of defects. And that is part of QC. That is how we QC the
So you saw that big piece of plastic. That's part of QC. Uh-huh. Sure it is, Christopher.
item. So we start off with a buzz bar or a bridge that is more than capable of doing the job. And then because this power stage has to go a little further, we make it.
You hear him say it again, has to go a little further, and yet you can see they're shorter. Christopher, do you have any idea how hilariously moronic you sound when you say stupid stuff like that, and everyone can see that they are shorter, not longer? You sound like a complete moron because, well, he is. He is a moron. He just says whatever, whoops, random stupid thing and just expects you to believe it. And I have this thing, I don't know, called a disease or whatever. It's called critical thinking. Yeah, I mean, look at how shitty the Kapton tape is laid. It's just like wadded up on there. I mean, could they do a shittier job at this at all? All right, let's let Chris lie some more.
Twice as wide, and to be able
It's
to
not twice
QC
as
it,
wide.
we put
He
a hole
says
in the
twice
middle.
as wide. The other ones, the upper bridge, or sorry, the upper stage bridges, they're about like 2/3 the width of this, so it's not twice as wide. I would say a quarter to a third wider. If we're just going to nitpick.
It doesn't create resistance because well, it does create resistance.
Yes, there we go, Chrissy. Finally, you say something that's true. All right, so if I had this section of copper right here and I put my milliometer from here to here, I don't know what the resistance will be. Let's just say 10 milliohms without the hole in it. When I make that hole in there, now the resistance is now going to be higher. Obviously, it will be. Um, but I don't know what it'd be. So let's just say it's going to be 10.2 or 10.5 milliohms now. You've just increased losses in this power stage. Never mind that you have massive amount of inductance in here, and it's not even balanced between the three phases, because this one here has much more inductance than this one does, which has even more inductance than this one does, just because you have these ridiculous paths to go through. So, yeah, this is very lossy. These holes simply add more losses. Yeah, that's the only time he ever says anything true, and I don't even think that he did it on purpose. It adds resistance, and you don't want added resistance. You want less resistance always. So let's listen to him lie some more.
Resistance, I guess, but resistance in a bar that's twice as wide than it actually needs to be is no resistance at all.
Uh, yeah, wrong, wrong.
It's just, unfortunately, these people online, guys, talk a bunch of nonsense when they have no real practical idea of how things work.
So he's referring to me, of course, because nobody else has done a teardown of a Rush controller. And supposedly I have no practical experience with how things work. So if you are wanting to do something, just skip through it. If you're not interested in seeing a motherboard repair, go look at the MacBook A2141 motherboard repair that I'm doing. I have to reflow the flash ROM chip for the T2 security chip. I have to pull that off the board. I have to reflash it, put it back down again. I've got an antenna connector repair I've got to do yet. So for somebody who supposedly doesn't know how things work, tell me how it is that I can work on something like that, which is far more complicated, far more sophisticated, with components way smaller than anything you'll ever find on a power stage. How is it that I can work on that and repair that motherboard? And yet, somehow or another, I'm completely clueless about a motor controller power stage. Go ahead, feel free to explain that one to me. I'm going to say that you can't. And the reason why you can't is because that's complete bullshit It's Christopher, basically doing more character assassination, basically slamming me because he knows he's lying through his teeth to you, and he knows that I am dead right. He knows I'm dead right, and he cannot ever, ever acknowledge that because the only thing he cares about, the only thing that slimy, greasy used car salesman cares about is getting money from you. That's it. So he will tell you any bullshit he can to get you to buy KO Moto products, including just absolute fabricate crap. Make up anything he has to get you to buy KO Moto products because he knows how bad they are. Let's listen to him lie some more because he's gonna.
And then the other thing is this caftan tape. So they've
You heard him say caftan tape. Listen to him again.
made a big deal about us using caftan tape.
Here he goes. He says it again. Caftan tape. I'm going to stop the video and go over to Chrome. Where's my mouse pointer? There it is. All right. So you just saw the picture of Bobby Bolivia. Let's go over to here. This is the Wikipedia page for Kapton tape. And you'll see right here, Kapton, Kapton, was invented by DuPont in the 1960s. Kapton remains manufactured by DuPont to this day. The name Kapton is a registered trademark of DuPont. So, Kaptan, I don't know what that is. Um, it sounds vaguely familiar to me, and this is the closest thing I could come to that. So, Kaptan, and he even says Kaptan once. Yep. So Kapton, or Kaptan rather, this article is about the fungicide. It is not to be confused with ethyl mercaptan, which is used as an odorant for liquefied petroleum, or Kapton, the other article I'm looking at, a type of plastic film. So Kaptan rather, is a pesticide, an antifungal agent. All right, has nothing to do with tape in any way, shape, or form. And he says Kaptan once, and then he says caftan, CAPH or CAFTAN, something like that, not Kapton. He never says Kapton, Kapton, which is a registered trademark name by DuPont. Yeah, and it's been in existence since the 1960s, for God's sakes. It's not something that was invented yesterday that people might confuse with something else. It's been around longer than I have by a lot. Yeah. Anyway, yeah, you just sound like a complete moron, Christopher, when you say caftan, captan, anything other than the trademark name of Kapton. Kapton, Christopher. Figure it out. Do some actual research, dude, so you don't sound like a complete flaming moron, because you do. Let's listen to Christopher blow smoke out his ass some more.
To insulate. So if you look down underneath there, there's, come on, baby, there's a whole bunch of room.
Whole bunch of room. You heard him say it. Whole bunch of room. So if anybody wants to do this, the gap between the bottom of this piece of copper and the battery minus bus is about 1.5 to 2 millimeters. It kind of just depends on how much this piece of copper bridging is floating or pressed down against this piece of copper, whether it's 1.5 or 2 millimeters. So anyway, it's somewhere in that range. So that's a whole bunch of room.
It's not that it's ever going to be under pressure or no one's ever going to jump on it. It's not load bearing of any description. So essentially, we don't need that calf tape.
We don't need that calf tape. I'm just going to be really emphatic about it. I never said anybody was going to jump on this. I never said that it was going to suffer any kind of mechanical loading, anything like that. I did say that this piece of copper would expand and contract and that it would fracture its solder underneath it, especially with how little is here. I did say that, but that's a completely different thing. That's called thermal cycling that's going to cause solder breakage. But he turns it into this other thing where somebody's going to jump up and down on the controller. Christopher, dude, you have to be a moron to get that out of what I said about thermal cycling. All right. And he also says that it's not needed. You heard him say it just a second ago. I'm going to talk about this a little bit more because we're not done here. So, on the Pro and the S-Spec controller, They use that copper strapping. That is a plumber's product. You can buy it in a spool at any hardware store. Some of it comes with square holes, some rectangle holes, some round holes in it. The holes are there on purpose. That's so you can put a screw through it. It's used to do things like hold up ductwork underneath your floor joists, copper water pipes, all that kind of stuff gets strapped up in place with that copper strapping. The holes are so you can put a screw through it. That's it. And just depending on who you get it from, it's going to have round, square, rectangular holes. And that's all that is. It's a very common product. I have a spool that I went and bought at my local hardware store. And, mine's got round holes in it. So what? And Christopher lied about that too and claimed that that was some kind of a patented heat release venting thing, which was complete nonsense, complete bullshit. He stopped saying that because he knows how stupid he sounds saying that kind of thing. All right, so uh, yeah, just love that kind of stuff. So anyway, on those bridges, the one closest to this copper stud on the battery minus bus is about a millimeter and a half, 2 millimeters away. I have photographs of the arcing that would happen from this edge to here. This is obviously not 1.5 or 2 millimeters away, but that's a real problem. Many KO Moto controllers have died from that arcing issue that would happen there just because the gap was so close. And it's not going to happen to everybody. It requires just the right circumstances for it to happen. It's an easy problem to not have. Just simply move the damn bridge further away from the battery minus post. Problem solved. But no, they never did that. So anyway, when you do have that arcing, the MOSFETs on that phase just catastrophically die, just instantly death for them. So your controller is now toast. Well, in this controller, you now have a millimeter and a half to 2 millimeters from here to here. Arcing is pretty much guaranteed, and you have a lot more surface area too. So arcing is going to happen there. And I'm pretty darn sure in making these boards this way with this added copper on them, they ran into that several times where arcing would occur between the bridge and the battery minus bus. And they could see the scorching on them. So it was really obvious what happened. And their solution was to wrap the bridge in Kapton tape because it has a very high dielectric. That means resistance to electrical current flow, okay? And so they put the Kapton tape on there to stop the arcing issue. It is flat out required. It is not, we did this because we're good guys or because we just care about you or some bullshit like that. They flat out need it to stop the arcing issue that would otherwise occur if it wasn't there. They have to have that Kapton tape on those bridges so that arcing can't occur. Period. He lied to you yet again. Let's let him continue blabbing on.
The reason we put it there is just as a safety measure. It's just there as a little bit added extra. If
Listen
any
to this
debris ever
explanation.
got
It's
down in the
hilarious.
controller or anything like that, any ferrous material that could rub or get down between and rub between this phase and the bridge.
Did you hear that? He called battery minus. That's the battery minus bus right there. He called that a phase. Maybe he just made a mistake. I make mistakes too. Um, yeah, I've literally never heard him ever call this battery minus ever, but that's what it is. And yeah, he called it a phase. Guy doesn't even know his own damn products. Okay. Yeah, and he's talking about some kind of piece of metal getting in there. Um, yeah, let's talk about that for a second. So this power stage and this power stage and the logic board are all inside a watertight box. So part of it is machined aluminum and part of it is ABS plastic with a silicone gasket between them. So pray tell, how is it that some ferrous material is going to get inside the shell and just arbitrarily land right here between battery minus and this phase bridge? How is it going to get right there specifically? Because that's the only place you put Kapton tape. Notice all of these MOSFETs, notice these bridges, all these other components. Those ones have no protection or isolation on them of any kind. They're just bare components. And that's perfectly okay because this controller is inside a waterproof box. No dirt or moisture or whatever is going to get to these components anyway. So how the hell is it that some piece of ferrous material is going to get in here and specifically bridge from battery minus to the phase bridge? How? It's just, his explanation makes no sense. None. Absolutely zero sense whatsoever. It is complete nonsense. Complete bullshit. He's just pulling this shit out of his ass and expecting you to accept it as facts. Yeah, the Kapton tape is not there for that reason at all. It is there because arcing will occur from the phase bridge to battery minus. That's why the Kapton tape is there. Period. That's the only reason why it's there. Yeah, and he talks about these inspection holes. That's so called. They are there, so you can see the MOSFET legs. So Chrissy, notice this big ass piece of plastic right here that's literally covering almost all the MOSFETs except for two in this third phase over here, completely blocking your ability to inspect the legs on those ones. You've literally ignored for here what your explanation for these holes is and for those notches are. You've got this giant piece of glass reinforced plastic covering up nearly the entire phase of MOSFETs over here. So you can't inspect those legs at all. So the explanation for your holes and little notches is once again complete bullshit as usual. Because you have this giant piece of plastic completely occluding any inspection of those MOSFET legs in any way, shape, or form. Let's let Chrissy keep going because he's got more bullshit to say.
Anything like that, there's something there to protect that, and that's that caftan tape. So really, it's not a
All right, so let's go to the second video in this.
cheap way of going about it. Something there to
Yeah,
protect that, and that's that caftan tape.
he,
So
he,
really, it's not a
he calls it a cheap way of doing it. Yes, I will agree. It is a cheap way of doing it.
what did they call it? It's not a cheap way of going about it. It's actually an added extra that we don't really need.
You hear him say it again. It's an added extra that we don't really need. I'm going to flat out say he's lying. It is absolutely needed because if it's not there, you cannot stop arcing from battery minus to the phase bridges. You can't. You need some kind of insulation between the two to arrest arcing issues. They know this. They're just lying to you and saying that, oh, it's just there, just in case some little metal bit. You know what? The metal getting in there is not going to happen. Let's just call it water getting in is not going to happen. Never mind metal getting in, which is a much larger object than water molecules are. He's just blowing smoke out his ass to cover up for the fact that the Kapton tape has to be there to arrest arcing between battery minus and the bridge. Because he knows full well that this is a really horrendously bad design and you can't deal with it the way it is. It needs to be massively redesigned from scratch. Get rid of all of this shitty work that's on here. Do it like KO Moto should have done it from the beginning. Copy EBMX. Copy Torque. God, both of those are great power stages. Copy the way Trampa does it. All of those are great power stages. This is just an absolute cluster of bad design work. Just band-aided and band-aided and band-aided. And Kapton tape is just one of the latest band-aids. That's all. We got to deal with that arcing problem that we know is there. So let's lie about it and say, oh, yeah, we're protecting you. We're good guys and we're taking care of you. And no, you're not. You're literally band-aiding a massive problem. Um, so don't remember if I already talked about this, but you can see these two bridges here. If these were robotically placed, like in advance of this entire board going into the reflow oven, then these two bridges would be placed identically. They wouldn't be crooked, and you already know they're crooked. You can't really see it in this picture, but you can see it on my boards. They would be both dead straight because a robot placed them. And yet this one here, this edge is right up to the edge of the comb, and this one here, you can see that it is not. So these were hand placed, and they also go down crooked a lot, and you can see all the hand solder work. They were obviously added after this board went through the reflow oven. So once again, seeing all those MOSFETs, yeah, that's so-called inspection. Never mind the fact you can't see those ones. He's just literally lying to you and expecting you to believe whatever bullshit he pulls out of his ass.
We do it just in case for the the odd reason that may eventuate that we
Yeah,
can't
it's called
foresee.
arcing,
We
dude.
put that
It's
little bit
called
of caftan
arcing.
tape on there before it goes through and gets heated and soldered. So there you go, guys, just a little bit of insight. Like I said in a previous video, we are going to show all this in our test video and side-by-side video with other brands. And sometimes we make design choices for really good reason.
They make design choices for really good reasons. So the only really good reason that KO Moto makes the design choices that they make is because they probably don't know how to fix this. That's my opinion. This is some prototype power stage that some junior engineer came up with. It worked, so they went with it, and nobody at KO Moto knows how to do it properly. They don't know how to redesign this. That's the only explanation that makes any kind of sense to me, why it is that they don't just fix this outright. Because if they did, they don't need two power stages. It's adding massive cost to this thing. This has got really unbalanced cooling on here. All the MOSFETs are on the top half of the board. You've got two power stages in here when one is gracious plenty. There's plenty of real estate on here to add, two more MOSFETs per phase in here. If this thing wasn't so damn lossy, you wouldn't need 48 MOSFETs anyway. You already have these really powerful MOSFETs. I forget what they are, 370 amps each. Yeah, if they were just implementing them right and not have so much losses in this thing would run like crazy. You wouldn't need these bridges because you would put your phase bridge or your phase bus right in the middle of the MOSFETs. The bridge would be completely extraneous at that point in time. Battery minus would go down on the bottom side of this board. Battery plus would go across the top. All that stuff would be reinforced. It would be beautiful, and I would love it. But they don't. I think they don't know how to fix this. I really think that they have no idea. All they can do is fiddle with things a little bit. And that's all they understand how to do. Clearly, they don't know anything about electronics because otherwise they would just abandon this. This is expense after expense after expense. They just band aid together and never do right. All these connectors, these are very expensive. They're extra. The copper's great. I do like copper. I do. But everything here is just these band-aids they keep doing, and they never fix the core problems with their power stage. Instead, they just make excuses for why it's that way and how it's so wonderful rather than just fixing their damn power stages because they suck. They are terrible. Let's let Chrissy talk some more.
And in this case, it's a QC reason. We can't
Yeah, it's a QC reason. Not.
see the legs on these FETs unless we have these little notches, and then to overcome.
Yeah, yeah. Holes in there so you can see those MOSFETs. And what about this giant piece of plastic here, Chrissy, that's completely blocking all those ones so you can't see the MOSFET legs at all? Yeah, it's because those bridges weren't there. They were added after the fact. And your explanation doesn't make any sense because this was put in here in the reflow process, in the reflow oven. Uh, Completely obscuring seeing those MOSFET legs. So your quality control explanation makes absolutely no sense whatsoever. And it's obviously more lies coming out of Christopher's obviously dishonest mouth once again. Yeah, the man can never ever tell the truth. He knows full well these were put on after the fact. He's there in the damn factory. He can see that this isn't on here straight. He can see that it doesn't line up directly. They were not robotically placed. They were hand placed after this board was built. After this board was all pick and placed, after it ran through the reflow oven. That's when those bridges were put in. They could see those MOSFETs right up front. No problem seeing them at all if that explanation had any water underneath it, which it doesn't. And never mind the fact that this is all covered up with plastic. So, yes, his explanation literally has no merit to it whatsoever. It's complete bullshit.
That on the power stage that has to travel a little further. We
Yeah, he says it
basically
again, has to travel a little further, and yet they're shorter. Do you not even pay attention to what you say, Christopher? Like, ever? You've said that it has to travel a little further, like, I don't know, 3, 4 times now, and it's still wrong every single time. It's abundantly obvious those bridges are shorter, dude.
power stage that's on the bottom, we make that bridge double the width and put a hole in the center so the ladies who QC the items can still go ahead and
I honestly think the guy believes that if he says something over and over again, that suddenly makes it true. That must be what it is, right?
QC. Now, if, I guess someone's going to pick out on this video that these are a little dirty. These are
Yeah, a little dirty. Yeah, he's going to say, "Oh yeah, we haven't washed these boards yet." Except for that somehow or another, my Rush controller arrived to me looking pretty much like that, so-called a little bit dirty. Yeah, sure, Christopher, whatever you say. It's because you don't wash your boards, period. You're lying yet again. I didn't get mine all dirty. I have no reason to sabotage your products. All I care about is showing them exactly as they are. And here you are, showing it exactly as it is, exactly how I got mine. They're covered in crap because you don't wash your boards. You literally don't care.
basically just come straight out of the heat bath, so they've just been soldered. They do get all cleaned up. The chap in question is saying that he's received one that's full of gunk and all this sort of stuff. It just doesn't happen.
It just doesn't happen, except for that it did and does happen, and you're lying yet again. Um, so I want you to see something that's very key here. Notice that this has got crap on here. He's about to flip this over.
Don't ship stuff like that. This has come straight out of
You
the.
see that? He's got the aluminum plate on the back of this metal core printed circuit board. That's because that is assembled. It's ready to go. Okay? The only reason why you'd have that board on the aluminum plate behind it is because that's how you're going to assemble it, just like that. So they are not going to wash it because they would have washed it before they put the metal core printed circuit board down to the aluminum because that's all got behind it, all thermal paste back there. Um, yeah, they would wash this board before they mounted it to the aluminum plate, not after. So he just lied to you again. No surprises there because that's what Christopher Kleinschmidt does. Lies, 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 lies. Every time he opens his mouth and says something, there is a 99% chance that the guy is blowing smoke out his ass again. So yeah, this board is mounted on that aluminum plate in there. So that's the middle power stage, and it's not washed. He just lied to you because that's exactly how they assemble them, exactly as you see in his hand, not washed.
The basically the oven, for want of a better word. It's all had been heated and had all its components soldered on. So there you go, guys. I hope that puts. Oh, there was actually one more thing I'll touch on too. This brace. So we've molded this brace up. This is a really high strength composite. It's not it is a plastic, but it's like a reinforced plastic, and that is there to hold these phases, so you can really lean on these phases. Now it all keys in.
Yeah, so yes, he's actually telling the truth here. This is glass reinforced plastic. It's not ABS because ABS won't tolerate the heat for soldering. This got to be some kind of a polyethylene, possibly. It wouldn't be nylon. That won't hold up to the heat either. I don't know exactly what kind of plastic it is. Um, but yeah, it's glass reinforced. It is a pretty tough plastic and it does tolerate a hell of a lot of heat. Definitely does that because this piece of plastic went through the reflow oven and it doesn't deform or whatever. Does it reinforce these studs so you can crank on them? Yes, it does. So they actually did something about the twisting off their brass studs. They actually did something about it, and that's this glass reinforced piece of plastic. But he's going to say something here, which is, again, patently wrong.
In from underneath, locks in. So basically, if you try and turn this one, you're trying to turn in the entire, what is it? It's 5 of them, the 3 here and the 2 here. You try and turn this one, all the pressure's on this. Try and turn this one, all that pressure comes back onto this. Excuse my fingers, I'm in the factory. And what was said is, why would they make it out of plastic? Well, geniuses, if we were to make this out of any conductive material, whether it's aluminium, brass.
Yeah, so here's where he's blowing smoke out his ass again. He's not wrong. If that piece of plastic was made out of some kind of conductive material, like say aluminum or brass, whatever, yes, they would dead short all these things together. Totally agree. Yes, that would happen. The problem is, though, dude, is you have a bad design for a power stage, period. And your band aid for one of your problems with it is to put a glass reinforced piece of plastic across all 5 of your studs so that they don't twist off, rather than redesigning your board altogether, like I've explained to you in my videos. You know what, Komodo, copy EBMX, copy Torque, copy Trampa. God, there is plenty of good designs out there. that have surface mount components that have studs on them similar to yours that don't shear off. And they also don't short all that stuff together. His explanation is a stupid explanation. This is a bad design with a band aid on it, period. Yes, the plastic does stop conduction between these studs, but that's all it does in that regard. His explanation of, oh, yeah, it's just the stuff they don't short together. That's so stupid. You know, KO Moto, your products all have this problem, and you need to put your little plastic reinforcing thing in all your controllers just so you can't shear off your studs. Yeah, this is better than that. I will grant you that. The real answer is copy EBMX. Their power stage doesn't suffer from sheared off studs, like never, ever, 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 because they did it right. Each one of their studs is well reinforced. You will never have that problem. The Torp power stage is the same way. Their studs are really well reinforced. There's lots of surface area around them. There's other controllers that have really good reinforcing on the metal core printed circuit board. And rather than redesigning their power stage properly, they just band-aided it with this piece of plastic. Yeah, his explanation is so full of holes. And you're looking at it, you can see that you can't see through those holes. You can see that you cannot inspect the MOSFETs underneath it. The explanation for these holes is complete bullshit. Truly, it is. They are some copper bar that had evenly distributed holes in it, and they just simply cut it in sections and put those holes kind of in the middle, and then he explains it away as inspection ports. What a load of nonsense. And yet, right here, you can't even see the damn MOSFETs under the plastic.
um, I don't know, copper. It would actually short out the phases with the negative and positive. It'd short out the negative and positive with the phases. The controller would blow up.
Actually, the controller wouldn't blow up. You just have a dead short across all of these. Yeah, it would never even get as far as the controller blowing up. Well, you would plug in your controller to power, and your connector would just explode. Yeah, that's what would happen. Not your controller would blow up. The real answer to this is redesign your lousy power stage so that it's not a steaming piece of shit like this is. And then you don't need this piece of plastic. Instead, everything is well reinforced, everything is laid out properly, losses are minimal. Yeah. Quit band-aiding this piece of crap, Chris.
So it can't be made out of anything else than a non-conductive material, essentially like a plastic. And it's there as a brace to hold all those things together. So when this all goes down and slots in together like this, so these all have a big bunch of bracing on them. They're not going to move. They're rock solid. So I hope that helps, guys. I hope that helps you navigate some of the BS online.
Yeah, the BS online is from Christopher Kleinschmidt. I mean, can you please say more stupid things, Christopher? Because it's hilarious, dude. It's just absolutely hilarious.
And understand that sometimes we make decisions for a reason. And
Yeah,
very, very good
because you're
ones.
cheap and you
All right,
can't
guys.
do a decent
Chat
job.
soon. Cheers.
Because all you make is crap and you band-aid it over and over again. That's your reasons for doing it this way. You just band-aid bad designs again and again and again and again, rather than do a proper design that works well, that doesn't require all this extra expense and a middle power stage. You know what? If you guys would just hire somebody, I've already volunteered to help them. I did. I tried to help them. I said, please don't sell the Rush controller. Please let me help you redesign it. I did not beg to join KO Moto. I begged them to not sell this steaming piece of shit, is what I did. And yet Christopher said, I want to go work for KO Moto. Like hell I did. I just didn't want him to sell this piece of steaming crap. So yeah, I was willing to help them redesign it. That's what I asked Chris. Let me help you redesign this thing so you don't sell that steaming piece of shit that you guys are already making and you're gonna do times two. Don't do that. Let me help you redesign this thing so that it works well from the get go. They would have so much better of a power stage and it would cost them easily half of what this costs because it would have been done right. It would have been simple. It would have been efficient. It would have had good design elements in it. Yeah, it would have been a kick ass power stage instead of this crap, this steaming turd times two. Anyway, I hope that helps some folks out. I gotta just say, Christopher Kleinschmidt, thank you for the ammunition in showing your own stupidity, your own moronic statements, your own just bad use of terminology. Yeah, and explaining things as something else when the honest truth is what things are. And I can see right through it because, well, I kind of know electronics a little bit, have an electrical engineering degree, I've been working with electronics since the late 1970s. You can see my videos. I obviously am not some dumb shrub. And Christopher, you obviously are, because I mean, damn, dude, your videos are just full of your flaws, full of your lies, full of your misstatements and misinformation and misdirections. Well, anyway, folks, I hope that helps you out. I find this kind of video highly amusing because my ammunition is Christopher Kleinschmidt. He's an absolute flaming idiot.